calculus, a bit of it actually, where we talked about the tables of functions, which I believe strongly that we're going to do that table very well. Your journey into calculus, differential calculus become much more easier. Then we spoke about the function of function at one time. I did it fit to bring to your notice the concept of, just basic concepts, the product rule, the quotient rule, that I'm going to be adding the implicit function to it. So they're not something, they're not big deals, they're not something difficult to know. You just need to know when and where to use them, so it becomes much more easier. So starting with the product rule, you get when exactly do we make use of the product rule? Imagine you have a function y, that has a function u, which is a function of x, and a v, which is also a function of x. You get the gist? Such that when I can write them as y equals uv, so you don't get too confused. Y equals uv. What is bringing this u and v together is product. U times v equals uv. That's where the product rule starts from. So, but don't forget that u is a function of x, this is a function of x, but I want it to be something concise that you can understand. I just write it this way. So when I was asked to use the product rule, what exactly am I expected to do eventually? Is that, or you ask me the question, when do I use product rule? When a function is backing another function with respect to product, we use the product rule. You get? I'm going to give you instances where that can be used actually. Look at this. So in other words, my dy dx is simply equals to u dv dx, being a function of x, plus v du dx. This is the formula for product rule, and the question is, when do I use it? Because there are many other concepts. So when do we use it? The moment you have questions such that they are in this form, a function x squared minus 1 backing another function 3x squared maybe plus 1 or plus 5, as the case may be, is called product. This bracket is backing this bracket. I have no other option than to use product rule. I have another function, say y equals e raised to power x sine x. This is product rule. I have another function y equals any function that can map themselves. Think of one, say a raised to power x, say in x. All of these are still applicable. Product rule is still applicable in all of these questions. Do you understand? So the moment I have a function of this form, what I do is product rule. Look at this number 1 now. I just say that my u is simply equals to x squared minus 1, and my v is equals to 3x squared minus plus 5. And then I'll say my du dx is what? When you differentiate x squared, it gives you 2x. When you differentiate 1, it gives you 0. Then dv dx is what? And we have 6x, and this one is 0. Then I'll now say my dy dx, which equals to u dv dx plus v du dx. Then I do simple substitution for computation. Dy dx also means y prime. So what is my u? My u is x squared minus 1. dv dx is what? 6x. Then plus, what's my v? My v is 3x squared plus 5. What is my du dx? My du dx is simply 2x eventually. I expand the bracket with no ones, so I have 6x cubed minus 6x, then plus 2x times 6x, 3x squared, like 6x cubed. Then this time this will give me 10x. Then I do a simple addition. 6x cubed plus 6x cubed is 12x cubed. Minus 6x plus 10x is 4x, and that's my answer eventually, without any stress as it were. Do you get this? Same thing with this our guy, number 2. Or, I don't know, maybe I should do number 3. I have y equals a raised to power x in x. What is my u? My u is a raised to power x. What is my v? My v is in x. What is my du dx? It's simply a raised to power x in a. What is my dv dx? My dv dx is 1 over x. Then what do I do my computation? My dy dx is u ax dv dx, which is 1 over x plus v ln x times du dx, which is ax ln a What will then give me? Ax over x plus what? Ax in x. Eventually, sure you understand. So, many things, hope that basic. So beautiful to do. Many things to be done. This one can now become, bring out ax, make equal 1 plus x. I have in in x. If I pass a law of indices and law of logarithms, it becomes ax 1 over x plus what? Plus log a base x. Eventually, then this log a base x eventually. Now, how do I get that? You know that in a is equals to log a base e, and in x is log x base e. So, and this one is still the same thing as, well, you say 1 over x of this. Let me say log AB is the same as 1 over log what? BA. The way you are taught in the law of logarithms, you can check that out too. Meaning that this, my guy, will become log A base x times 1 over log E, log A base E base x. Okay, log E base x. So, okay, let's just read this way. It's not, I was thinking it was applicable, but definitely not applicable. So it's best to just read the way I was just initially. By saying what? By simply saying the what, the A, the X eventually. So it's one thing I believe is easy to do, to make you understand the process as it were. So that is that for product rule. So let's quickly look at the quotient rule. Okay, for the quotient rule, the difference between the quotient rule and the product rule is that the quotient rule is applicable when the question comes in form of a fraction. It has a numerator and a denominator, or it is convertible to a fractional form. Then I just use my quotient rule. And by my quotient rule, I mean that I have my y to be equals to u over v, obviously a function of the x. Then you get this. It's always in fractional form, so that my dy dx eventually becomes v du dx minus u dv dx all over v squared. This is the formula for quotient rule. Do you understand? So when is this applicable? It's applicable when my question is occurring in form of a fractional form. It's occurring in form of a fractional form. The moment I'm having a question that is coming as fraction, then we refer to such as quotient rule eventually. When it is of this form, we call it a quotient rule. When it is backing itself, we call it a quotient rule. Do you understand? So, that being said, if I was to deal with rule number 1, you can, having that knowledge already, you can deal with any other question if you know how to, which you can easily jump on from the previous videos. We have y equals e raised by x, then what? Then sine x. My u, because I v. My u is e raised by x, my v is what? Is sine x. Then du dx is e raised by x, then dv dx is cos x. If that is the case, my dy dx is now equals to v. What's my v? Sine x du dx e raised by x minus u, which is e raised by x, dv dx, that is cos x, all over v squared, that is sine x all squared. So the u dx is the same thing as y prime. So I have it equals to e raised by x sine x minus e raised by x cos x all over what? Sine squared x. What does that mean? E raised by x is common to both of them. You can come out and have sine x minus cos x all over what? Sine squared x. And that's my derivative already. So that's my answer. The same is applicable to this and even this. I didn't have to say as in the textbook eventually. All we need to do is just understand how those things work. Then we apply to many more examples as you can be hands on. Then you become an expert in it. So the last of which I'm going to be looking at is called the implicit function. Kindly stay with me. So for the implicit function, the difference Well, I think I just spelled it out that all the equation we've been dealing with so far is called explicit function. And that's because we can know definitely what which of the variables is dependent and which of them is independent. But for implicit function, we can't know which of them per se because they are interwoven together. So it's called the implicit function, or like the explicit, where I can tell you that x is independent and y is dependent. So the implicit function is basically of something like saying x squared plus y squared equals to maybe say 25 or 15 as case may be. You get it can be x squared y minus y raised by 3 plus say 5 equals to 0. It could be 3s cubed y squared x plus x minus y equals to 10. It's just something like this. At this point, you can't tell me categorically which of these is dependent, which of it is independent. Unlike the explicit where I have y equals 2x squared minus 1, y equals x plus 1, as it is to be. I know without stress that this is my independent, or you get what? I know. So it makes it easier for me to know which of those variables is dependent and which is independent, and that is called explicit function. But now we are dealing with what we call the implicit function. The implicit function. Do you understand? So if I was asked to find my dy dx of these followings, especially if I was using the form, maybe solve for dy dx of these guys, what do I do? I was given, say, x squared plus y squared equals 15. It has a little technicality that is different from the one we have known initially, though the concept is still the same, is that whenever I differentiate a variable y, which I expect to be independent rather, I'm going to put the y dx inside it. So when I differentiate x squared, what does it give me? 2x. When I differentiate y squared, what does it give me? 2y dy dx. And this will give me a constant, gives me 0. So eventually I have 2y dy dx to be equals to minus 2x. I can divide both sides by 2y. So dy dx is now equals to minus 2x over 2y. So dy dx is equals to cancel minus x over y. Now that's my answer. That's the dy dx. But what if you're now asked to solve for the value of dy dx at a point 1, 2, which do occur? It means here will become my x, here will be my y. So I will have dy dx is equals to minus 1 over 2 as my answer. That is if I was given the point of solution. You get the gist. And the beautiful thing, like I always said, is that it's not different with others. And I will try to solve all so you can understand what I'm trying to say. I was given x squared y minus y cubed plus 5 equal to 0. Now, how do I do this? Well, don't forget that is the only time I'm going to bring a dy dx into the picture is when I'm differentiating the variable y. Now, I want to differentiate the variable x. The moment I'm differentiating x, I will look at y like a constant or as if it never existed. So you can cover it up if you like. You can just snub it if you like. If you are good at snubbing, then what does this become? It becomes differentiate x, it becomes 2xy. I don't need to put dy dx there because what I differentiate was just x. Then there's a y beside this. Now I want to differentiate y. I will now say differentiate y. When I differentiate y, it gives me 1. 1 times x squared gives me x squared. I will now put dy dx, and that is because it was y I differentiated. I go further to saying this is y. So differentiate y. I have 3y squared, and I put the y dx inside it because I'm differentiating a y. Then differentiate 5 is 0. So I have 0. Then I will simply correct like terms. So it becomes x squared dy dx minus 3y squared dy dx equals to minus 2xy. So correct like terms, I have dy dx equals x squared minus 3y squared equals what? Minus 2xy. Divide both sides by what? Divide both sides by x squared minus 3y squared. So dy dx is equals to minus 2xy over x squared minus 3y squared. If again you are given to solve it at a point, solve for dy dx maybe at a point 0, 1, it means my x is, no, let me just say 1, 1. You get this? My x is 1, my y is 1. So what does it give me? The y dx gives me minus 2 times 1 times 1 all over what? 1 squared minus 3 times 1 squared. That is minus 2 over 1 minus 3, and that is what? Minus 2 over minus 2, which equals what? 1 eventually. And that is the mind behind it. It's beautiful. Because you can think these things, this kind of things through, make it very, very beautiful. Let's try number 3. I'll give yours to you. I just want to make you know for sure that this is not difficult as we have assumed. X, y equals 0. Do you understand what I'm doing? Now, can you help me out? I want to delete x. What will be my answer? Yes, you are right. 9x squared y. The next, I want to differentiate y and z. What will be my answer? Yes, you are correct. Now, 3x cubed dy dx. I want to differentiate x here. X here. What will I have? I'll simply have y squared. I want to differentiate y here. Don't forget, I'm putting y minus because there's minus here. I'll simply have 2yx dy dx because it was y I differentiated. Here, I want to differentiate what? X, I have 1. And here, I want to differentiate y. What will I have? Minus dy dx equals to what? Is 0. So, collect like terms. Meaning 3x squared dy dx minus 2yx dy dx minus dy dx equals what? To equals y squared outside minus 1 because plus 1 has gone out, then minus 9x squared y. That is what to do. What is common to the 3 of them is dy dx. Bring it out, what we left? 3x squared minus 2xy. It is commutative. Minus 1 equals y squared minus 9x squared y minus 1. So divide both sides by this guy, and we have dy dx equals y squared minus 9x squared minus 1 all over 3x squared minus 2xy minus 1. And that will be my answer. So you can try that out at point minus 1 and 0. What will be your answer? I will do the first session. But in addition to that, can you just try on your own to differentiate 2xy minus x minus y equals to 10, and maybe say you are saying 3x squared y3 minus xy cubed xy squared minus y equals to 100. What will be your answer? Deal with this at point 1,1 and point 0,1. What exactly will your answer be? I would like to get your feedback from the comment section if you don't mind, and I will implore you to go back and do a lot of work on yourself, and assure you that the work has become much easier than you ever think. Thank you for being part of this class. Please do to subscribe and turn on your notification bell so that you can be updated whenever new videos are uploaded.